Hello, pre-algebra class. Welcome to another episode of Mr. Chow Time. Today, we are working on negative exponents. Lesson 2, page 141, if you're following along the book. There's only one vocabulary word this time. It is negative exponent, which is the operation indicating how many times a base number is divided, which kind of makes sense, right? Because division is the opposite of multiplication, and negative is the opposite of positive. So a positive exponent is multiplication, a negative exponent is division. And here is a little chart to kind of illustrate the point. So if you have a number like 10 to the third, that is the same thing as 10 times 10 times 10, right? And if you were to divide this by a 10, then that would cancel one of these out, right? That would be like 10 to the third over 10 to the 1. And so as we go down from 10 to the third to 10 to the second, you're dividing by 10. And then you're dividing by 10 again, and so on and so forth. And so each simplified number, as you can see, is getting 10 times smaller each time. So let's take a look at some examples. Here we're going to write this as a positive exponent. So right now it is the negative exponent, negative 3. But a negative exponent is the same thing as dividing, right? So we can write this as 1 over 2 to the third, because now we're dividing by this number. And so you can say it either way, 2 to the negative 3 or 1 over 2 to the third, because here we're dividing and here we're also dividing. So let's do that again, but now with this expression with the variable. So here, instead of m equals, or m to the negative fourth, we can say 1 over m to the fourth. Okay? All right. Your turn. Write each expression using a positive exponent. Welcome back. So this would look like this. This would look like this. And this one, kind of a tricky one, right? So if we think about 2 to the 1 as being 2, well, if we were to divide this by 2, what would we get? We would get 1, right? Any number, any base to the power of 0 equals 1. Okay. Write each fraction as an expression using a negative exponent other than negative 1. So if we did not want to write this, write each fraction as an expression using a negative exponent. Okay, so now we want to say this is a negative exponent. This is going to be 4 to the negative 2. And this, what it's saying is that they don't want you to write it like this, although you could, but they don't want you to. What they want you to do is write it like this. 10 to the negative 2. Okay, so this is the same thing as 1 over 10 times 10, right? Which is the same thing as this. Okay. Your turn. Welcome back. Again, they want you to write it as something other than negative 1. So this would be 6 to the negative 3. This would be 5 to the negative 2. And this would be 3 to the negative 3, right? Because this is the same thing as 1 over 5 times 5, right? And this is the same thing as 1 over 3 times 3 times 3. Okie dokie. Let's take a look at this real world example with geckos. Geckos are, we have a lot of geckos here in Taiwan. They're those little lizards that you see like everywhere. They eat bugs. They're great. They have these little tiny hairs on their feet that are 0.000001 meter long. So write this decimal as a fraction. So to write it as a fraction, remember, we just count the number of place digits after the decimal. And in this case, there's 6. So that means we just put the number over 1 with 6 zeros. And what is the number? It's 1. So it's 1 over 1 million, right? So 1/1,000,000th of a meter long. And then we're going to write that as a power of 10. So that would be 10 to the negative 6 because we have 6 zeros. Your turn. The slowest moving fish is a seahorse. It swims at a maximum speed of 0.0001 mile per minute. Write the decimal as a fraction. So again, 1 over 10,000, right? Because there's 4 digits, so there's 4 zeros, which is 10 to the negative 4. That's a 4, not a 9. One more, your turn. The smallest species of ant has a mass of 0.00001 gram. Write the decimal as a fraction and as a power of 10. Welcome back. Okay, so this is going to be 1 over 5 zeros, right? So 100,000, it's 1/100,000ths. So that's 10 to the negative 5. Oh boy. My daughter is really playing some games back there. Okay. All right, evaluate expressions. Algebraic expressions containing negative exponents can be written using positive exponents and then evaluated. So here we have 4a to the negative 5th. And the negative 5 only applies to the a, right? So this is going to be 4 over a to the 5th. Because the only thing that's being divided is the base a, not 4, because there are no parentheses here. And so let me just take a second to talk about positive and negatives. So if you have a negative base, such as -2, being multiplied an even number of times, then that's going to be a positive answer. If you have a negative base being to the power of an odd number, then your answer is going to be negative. And the reason is because, let's just do this really quickly with 2 and 3, just as an example. -2 times -2 is going to be a positive number, right? And if we had 2 more of these, that's still going to be positive. And a positive times a positive is going to be a positive. But an odd number, you're going to have a positive, and then you're going to have this leftover negative, right? And no matter how many of the positives you end up having, you always have one leftover negative, right? And so when you take a negative and a positive and you multiply it, you always get a negative. So if the power is even, the answer is positive. If the power is odd, then the answer is negative.
Okay, so let's look back at our equation.
Okay. So 4 over a to the 5th is 4 over -2 to the 5th. This is an odd power, right? 2 times 2 5 times is 32. So that's going to be a -32. 4 over -32. Can we reduce this? Yes, we can. That's 4 over -8. I'm sorry, 1 over -8. So the answer is -1/8. Okay, your turn. Welcome back. So this is going to be 1 over m squared. M is 4, so that's 4 squared. So that's 1 over 16. Here we have 6mn to the -4. So we have 6m over n to the 4th, right? And then we have 6 times 4 over 3 to the 4th. So this is 24. Actually, yeah, we can. I'm going to talk about this really quick. You can, oh no. Yep, here we go. Good. You can reduce this first, because you can think about this as 6 times 4 over 3 times 3 times 3 times 3, right? And so this 3 and this 6 can cancel out, right? And that would give us 2 and 1. And then we're done. So now we have 8 over 27. So if you want, you can reduce first. If that is too complicated for you, that's okay. You could just have multiplied, and that would have given you 24 over what's 27 times 3? 60 74? Is that right? I don't know. Oh boy. Let's see. 27 times 3. 81. 81, of course. Should have known that. 8 over 81, and then you could have reduced this to this point. Okay. Last your turn. Nope, that's it. Oh, no, this is last your turn. Okay. So if we have negative n to the negative 3, oh, my pen got way smaller. Then this is the same thing. Nope, that's too big. As 1 over negative n to the third, right? And negative n, so this is another one that might have been a little bit tricky. So negative n is the same thing as opposite n, right? So this is the same thing as 1 over negative 1 times n to the third. And so what do we do first? We're actually going to do this first, right? Simplify the exponent. So that's going to give us 1 over negative 1 times 27, which is 1 over negative 27. So when you have a negative in front of a variable, you can think about that as a negative 1 times that variable. And because you're doing multiplication, that comes after exponent in the order of operation. So we'll do the same thing here. This is basically negative 1 times 4 times m to the negative 2, right? And this one matters less because the negative 4 is not attached to the m. I'm sorry, the negative is not attached to the m. So you could still just write it as negative 4 over m squared. And m is 4, so that's 16 over negative 4. So this is negative 1 over 4. All right. Have a good day. See you later.